Hey, welcome back everybody. Gary Simmons here for the Game Institute, and this is lesson 38 of the game development series. In this lesson, we are going to add some layers to our animator that is going to allow us to manifest visually via animations any upper or lower body damage that our zombie Jill has received. Now, you will recall from earlier lessons that we've already implemented the system that keeps track of the damage levels to the upper and lower body. In fact, we even have parameters in our animator controller's parameter list called lower body damage and upper body damage, and our AI zombie state machine, every time our zombie takes damage in that take damage function, updates these parameters with the current damage levels. And so far, all we've used those for is on our cinematic layer, we check whether the upper or lower body damage is past a certain threshold, and that determines when we've been ragdolled what state we come out of the ragdoll into. So in the case where we've received so much damage that we're now in a crawling state, then we're going to animate into a crawling zombie. If we're not damaged at all, then we're going to get back up onto our feet here. And in the case where the body has been ragdolled and its lower body damage is 100 and its upper body damage is 100, then it's just going to go into an animation that sees the zombie essentially just led there wriggling, unable to do any sort of meaningful locomotion. And just to remind you, if we open up our AI zombie state machine class and go down to the take damage function, remember this is the function that is called on the zombie whenever it's been hit by a weapon. And you'll see, just to remind you, we did cover this in detail, but the amount of damage that is going to be caused to the zombie is passed in, and we use this to update the upper body damage or the lower body damage depending on whether the body part that we've hit is assigned the upper body tag or the lower body tag. Now, you could take this a step further than I do, and you could have things such as the lower body left tag, lower body right tag, an upper body left tag, and upper body right tag. So if you wanted to, you could really keep track of not only whether damage has been done to the upper or lower body, but also which side of the zombie the damage has been done to. However, I don't do that, okay? And the whole system is in place if you want to do that, and I hope you do and take it further than I do. But all I do at the moment is say, look, there's just lower body damage and upper body damage, and when lower body damage is past a certain threshold, we're going to turn up a layer in the animator that's now going to animate the lower part of the body with a limp. So that does mean it's not that accurate. For example, if you shoot the zombie in the left leg, for example, you might expect it to get up and limp such that the left leg is being dragged behind it. But if we decide that we're going to use a right limp, then it's not really going to be the right leg limping. But that's something you can implement yourself. For the most part, it's not something you're going to really be that aware of when you're playing the game, because whenever we shoot a zombie in the legs, they always fall down and ragdoll anyway. So all I'm after really is that once the zombie is ragdolled, it's going to get back up onto its feet. And we're going to see that the speed of the zombie has now been hampered. It's walking much more awkwardly with a limp, and that just shows that we've damaged its legs, and it's now going to be easier to get away from. Finally, just above the take damage function, we also have this little function here called update animated damage, and we call this function pretty much anywhere. Here you go, where we update the upper and lower body damage, or we update the crawling status of the zombie. And this function here just makes sure that the parameters in the animator stay synced up with the actual values in the zombie state machine. So in other words, if we get lower body damage, we call this function and we make sure that the lower body damage parameter in the animator correctly reflects this new value. So let's start working on Jill's animator, and the first layer that we're going to add is going to be the layer that is going to animate the lower body of the zombie when there's lower body damage. So to bring up the animator, I'm going to select OmniZombie Jill in the hierarchy. I'm going to select her AI entity game object, which has the animator component on it, and then I'm going to go to the Windows menu and I'm going to choose Animator. Dun, dun, dun. And we're looking at her base layer there. If you're not seeing the layers, it's because you've got the parameters tab selected. So choose layers, and then what we're going to do is click the plus sign, and we'll call this new layer lower body. Now what we want to do with this lower body is we want to move it up so that it's after the base layer but before all of the other layers, because the lower body layer is going to have animations on it that is going to override the locomotion animations on the base layer. But we also still want the attack and the hit and the cinematic animations to completely override our basic locomotion animation. So that's why it needs to be between the base layer and the attack layer. So let's select our new layer. As you can see, it's pretty empty. Now, what we want to do is basically copy the basic locomotion setup from our base layer so that we don't have to create all of these transitions again. Now, the lower and upper body layers are not going to have to worry about duplicating all of this crawling logic here, because when our zombie is in a crawling state, we're going to make sure that the layer weights for the lower body and the upper body damage are either set down to 0 or executing an empty state. So we can use the crawling locomotion from the base layer, but we do want to copy this basic setup here of just the locomotion so that we don't have to create all of that again. Because remember, this lower body layer is really going to be a drop-in replacement for the animations that were happening on the base layer. And in the case of the lower body layer, it's going to have a lower body mask on it, so that if we've got lower body damage, although the lower body layer is going to be animating the legs, the base layer is still going to be executing all of this basic locomotion logic and still animating the upper part of the body. Unless, of course, we have upper body damage as well, and then we're going to turn up the layer weight of our upper body layer, but we haven't created that yet. So I've selected all of these animation states. I'm going to go to the edit menu, I'm going to choose copy, and then I'm going to go to my new lower body layer, and I'm going to paste that in there. And look at that, it didn't select all the transitions. That sucks. Okay, so I guess what I have to do is select all of this stuff, right? Like that, maybe. Select it with the transitions as well. That's what I'm hoping. There you go. So we don't need that crawling state, so we'll delete that. Okay, so what we've got now is an exact duplicate on the lower body layer of the basic locomotion states on our base layer with all the transitions still intact. So what we can do now is we can drill down into each of these states and we can change the motion field that's going to be used. And in fact, this is how we're going to create lots of different types of zombies. This is what's so great about what we're doing. Once we have a final animator controller for Jill, we can duplicate that animator controller lots of times, and then we can just go into each copy of the animator controller, and leaving all of the states and all the transitions intact, we can just drill down on all of the locomotion states and just change the motion fields for different walking and running animations so that all of our zombies are not animating using the same animations. And then of course, once we've got, I don't know, let's say 9 or 10 variants of animator controller using a variety of different motion fields, we can just assign those to our different zombies as we see fit. So the next thing we want to do is create an avatar mask for this layer so that the animations on this layer only affect the lower body. Now, I'm not completely convinced that's how we're going to do it. We're going to have to see how the limping animations blend with the standard locomotion of the upper body, so we may not use it. But what I'm going to try to do first of all is say that the lower body layer is only going to affect the lower body of the zombie. So in the case where there is no upper body damage but there is lower body damage, the lower body layer is going to be making the legs limp, but the upper body will still be controlled by the base layer doing its usual upper body locomotion, and we'll see how that looks. So I'm going to go into my project view, I'm going to open up the Dead Earth folder, and I'm going to scroll down into a folder we created many moons ago called Avatar Masks. There it is. And at the moment we already have an upper body mask that completely cancels out the lower body. We want the complete opposite of that. So I'm going to create a new avatar mask. I'm going to call this lower body mask. Then with the lower body mask selected, I'm going to unfold the humanoid drop down, and I'm just going to turn off all of the upper body parts, including the hands and the IK solvers, like so. So just the lower body is going to be affected by any layer that is using this mask. So with our lower body mask now created, let's click the little cog next to our lower body layer in the animator, and let's click on the avatar mask selector, and let's choose our new lower body mask. Now, if I were to press play at the moment, obviously nothing would happen, because if I call up the settings of our lower body layer again, it currently has a weight of 0. So because we haven't yet created the logic that's going to turn this weight up and down based on when the body receives damage, what we'll do for now is we'll just force it up to 1 for testing purposes, okay? And I'm going to select Omni Zombie Jill's AI Entity Game Object, and I'm just going to give us some lower body damage. Now, you remember we have some settings here in our zombie state machine, and one of them is the limp threshold, which is set to 30% damage, which basically means that when we receive more than 30% damage to our lower body, what our code is going to do is turn up that lower lower body layer in our animator, and our zombie is going to start limping. So what I'm going to do is just put up the lower body damage up to say 50%. So we know that's definitely triggered the limp threshold, but we're not yet over the crawl threshold. Of course, we haven't yet put the code in that's going to test this lower body damage value and turn the weight up when we've realized that it's past the limp threshold. But for now it doesn't matter, because I've just put the weight up to 1 anyway for testing purposes. So if I press play now, what we should see with Zombie Jill is nothing should change yet. And that's because although we're now using the lower body layer to animate Jill, the animations in the lower body layer are exactly the same as the animations that would be in the base layer. So technically what you're seeing here is no difference, although technically what's happening is our lower body is actually animating the lower part of Jill, and our base layer is animating the upper part of Jill. So what we need to do now, of course, is find some animations that we can use to replace the motion fields in these states in the lower body layer. So let's drill down now into our animations folder, and where are they? I think I have them in the damage folder. Yes. So in this folder we have a few animations that we can choose from to use when our zombie is walking and it has lower body damage. So for example, if I do zombie injured 5 left and we play that one, let me bring up the size of the preview window. You can see this is a zombie walking with a limp. We have left and right versions of that one, so we can choose which one we want to use, and maybe use different ones in different variants of the controller a little bit later on. This is, I think, more of a limp with a purpose. So what I think we'll do is we'll use this for the zombie jog and zombie sprint states. This is basically our zombie at its full speed. And then when he's casually walking, we'll use this zombie walk injured 2 left, which as you can see is a little bit more meandering, not really like he's heading for a goal with any urgency. But before we assign those, what I need to do is drop into the idle folder, because we need to find an animation to use for our lower body when it's damaged for when we're idling. And as you can see, I currently have the idle state selected in the animator, so what we really need to do is change the motion field to another idle. So let's have a look what idles we have. Well, we have quite a few really weird ones here. Like, look at this one. This is called Zombie Idle Unstable 1. It looks a little bit more like he's drunk, doesn't it? Let's try this one. Zombie Idle Unstable 2. Not too bad, but I still think it's a little bit overblown. I think the one that I want to use is this one here. It's called Zombie Idle Alert. And as you can see, it's a different idle to the one we're normally using, which is much more alert and bouncy. But the legs are pretty much planted in the ground, which I think makes them look like they're damaged, but he's not drunk like some of those other animations. So that's the one I'm going to use, Zombie Idle Alert. But you can experiment with these and use whichever ones you want. And of course, you're not limited to just using the animations I provided you with. There are literally thousands of animations on the asset store that you can choose from. So I'm going to select Zombie Idle 1 again. Let's go into my idle animations, and which one did I say it was? Zombie Idle Alert. So I'm going to drag that and drop that in the motion field slot there. Sorry if you heard a little bark there. That's my boxer dog Dallas. Obviously just seen the postman coming into the garden, so please try and ignore that you heard that. Okay, so when I press play now, we're now going to use at least the lower half of this new animation. Now the animation is not going to look exactly like this, because like I said, it's just the lower half we're using. The upper half will still be using the locomotion from the base layer, which, remember, is this idle state here. So let's see what those two look like blended. So I'm going to call up the scene view, select Zombie Jill, press play. Let me get rid of her. Yeah, that looks different. Yeah, I don't mind that too much. Let's press play again to see what that looks like. Yeah, I like that, because it doesn't look so deformed that when it goes into a limp afterwards it's going to look weird, but it does look like the zombie has its feet planted and is trying to move them as little as possible. So I think I'm going to go with that one. And of course, it's going to be really cool when we have some zombies that are damaged, some zombies that aren't, and they're idling and they're all using different idle animations. Will really help the scene look more organic, especially when we have different variants of the animator controller. Okay, so going back to Jill's animator again, calling up her lower body layer, what we need to do now is find a new walking animation. Remember, our current walking animation is this one, we now want to change it for that limpy one that we found earlier on. So the same logic applies. We select the zombie walk animation in that layer so that we can now change the motion field. I'm going to drill down into the locomotion, and I think the one I wanted to use, sorry, not locomotion, into the damage folder. I think the one I wanted to use was this zombie walk injured to left. So I'm going to open that up, find the animation, which is called 9124, and I'm going to assign that. Let me just double check on it so I can see what it looks like. That's cool. And then what I'm going to do for zombie jog, I'm going to assign that other one, which once again is in the damage folder, but it's called zombie injured 5 left. And just to remind you, this was one that was still a limp, but it had a little bit more urgency to it. That's going to be our new zombie jog. Okay, so selecting the zombie jog state in the lower body layer and drilling down into my damage folder, I'm going to drag over the animation clip that is inside zombie injured 5 left, called 10525. Should probably give these better names. And I'm going to copy that into my zombie jog state. Now, our limping zombie is not going to have a sprint state. So what I'm going to do is I'm going to use the same animation for zombie sprint, but I'm probably just going to speed up the animation a little bit using the state's speed parameter. So once again, I'm going to select zombie sprint, drill down into my damage folder, drag over that 10525 animation clip, and maybe I'll just put this up to 1.25. Okay, so obviously we haven't found new turns yet, but if we press play, we should see our new idle animation on the legs, and we should see him when he starts walking now, the lower half of him should walk with a limp. And you can see it does that actually quite elegantly, and it blends quite nicely with the upper body animation that is just a zombie in its usual state. So I'm pretty pleased with that. They actually look like they're made to go together. So here she is hobbling. Now when she sees the food, what we should see her do is pick up a little bit of speed, because she's going to go into that sprint animation, which is going to be a slightly faster version of that same hobbling animation. Yeah, that doesn't blend with the animation correctly for the top half, does it? Okay, so that's what I was afraid of, and it means we're going to have to change our plans slightly. Just to be clear, everything is working exactly as it should. It's just that in reality, some animations that are animating the lower half of the body just don't look that good when blended with animations on the base layer animating the upper part of the body. And I think the problem is, if we select the lower body layer and open up the zombie walk animation, we can see that when a zombie is limping, it really affects the whole body. And therefore, I think what I'm going to do, and there could be many ways to solve this, but what I'm going to do is I'm going to remove the mask from the lower body layer. And I'm going to say that when we have lower body damage, this layer is going to play and it's going to take over the entire animation of the skeleton. Okay, so that we actually get this full animation. And that way, we won't have to worry about trying to find animations in the base layer that look good when combined with animations in the lower body layer. Because of course, what we saw was when we were in idle and when we were walking, these animations blended quite splendidly with the lower body sort of limp animation. But this one here, where you can see the hips are really swaying from side to side, having this upper body motion on top of a pair of limping and slow limping legs at that really didn't look right. And probably with the sprint, the situation is going to be even worse. So what we're going to do is we're going to remove that lower body mask that we made. We don't want that anymore. And then what we'll do later on for the upper body is, I think the upper body layer will have a layer on top of this that will make one of the arms sort of hang down, go limp. And that can either be blended with the base layer, or in the case where the lower body layer now has supremacy, will be blended on top of that layer as well. So when we're in the lower body damage, we've got that full body limp, but then the top half of the animation is going to be taken over by essentially this animation here. Imagine just the top half of this is being used, and you can see that I'm not quite sure which shoulder would be damaged in this case. I guess it would be the one hanging down or the one that's being held up awkwardly. Well, I don't suppose it really matters, but we can see that something definitely looks damaged there. We have left and right versions of that, by the way. So if you do decide to implement left and right body damage in a way that I haven't, you've got variants that you can choose there. Okay, so I've removed the lower body mask and I'm going to go to that sprint, and I'm just going to speed that up a bit to about 1.75. Going to make it quite a bit faster, and I'm going to move up just the zombie jog to about 1.25. Although when we went from a injured walk to an injured jog, the animation was a bit faster. It wasn't quite fast enough. So we're going to try that now. Just to be clear now, when the lower body layer is up, it's completely cancelling out any of the animations on the base layer. And of course, we'll need to make sure now that in our code, when we are crawling, we need to make sure that that lower body layer is turned down, so that we don't lose all of this crawling logic and the state machine for the crawling animations on the base layer. We'll still need those to come through. So let's see what happens now. So there she is. She's injured. Yeah, that looks quite a kind of injured stance. Okay. Now she's limping, and of course this looked good before, but it looks even better now because we're getting the full body animation for the limp. And now when she goes into a jog and ramps up into a sprint, when she comes around this corner, we should see something that looks a little bit more natural. It wasn't ideally how I wanted to do it. I would have liked to have kept the lower body and the upper body completely separate, but in reality you're going to have a nightmare with trying to find like animations that are good and that also blend together in all the various different combinations. But it was worth a try. So she's, there you go. So she's now seen the food and she's limping towards the food. Yeah, that looks perfectly good, perfectly natural. That's cool. Okay. So our lower body layer is almost done. We just need to find some turn left and turn right animations to use when the zombie is seeking left or right. So just to remind you, at the moment it's using the same turning animation as we have on the base layer, which of course is a very undamaged, alert, kind of aggressive seeking motion. So we want to find something a little bit more docile. So I have something that I think will fit the bill quite nicely. So if I go into my Dead Earth Animations Game Institute and Turns directory, we have a couple of options. We have this one here, which is called Dazed Turn on Spot Left. Yeah, I mean, it's okay. It's not going to set the world on fire. We also have this one here, which is called Zombie Limp Turn Left, which isn't bad, but I quite like this one here, which is called Romero Turn on Spot Left. Now, a lot of people are kind of split on this animation. I really like it. Some people really hate it. And when I say some people, I mean my boss, Joe Minahan here, Game Institute president. But I like that one because I think it's kind of really laboured, and we can tell that that is one damaged zombie. So I'm going to use this one for turn left, and I also have a right version as well. Of course, if we didn't, we could just mirror it in the actual animation state itself. But as I have two motion fields that have already been mirrored, I'm going to use those. So I'm going to select my zombie turn left, and I'm going to replace the motion field from what it currently says, which is zombie turn left, and selecting my turns folder again, I'm going to drag over Romero turn on spot left, drag that in there. And I'm going to put the speed back down just to 1. We've got it set on 1.5 because that's what we set the turning speed to on the base layer. Because remember, we just copy and pasted this stuff. So I'm going to put it back down to just the default playback speed. I'm going to do the same for turn right as well. And go back to my turns folder, and I'm going to drag over the right version of that Romero turn on spot as well. So Romero or Romerep turn on spot right, that one here. Okay, yes, okay. And I think what I'm going to do, because these animations are a little bit slower, and remember that the way that our locomotion is set up, if we're walking, jogging or sprinting, when we go into a seeking turn, we actually drop down into idle first, and then from idle into the left or right seek, and the opposite is true as well on the way back out of seeking back into a walk or a jog. So I think what I'm going to do is I'm going to make the transitions from the idle into the seeking animations and back into the idle again a little bit longer, because at the moment it's just 1/4 of a second, which isn't very long. So I think I'm going to make it maybe 1¼ seconds, so quite long. I'll do the same on the way out. That's just going to make sure that we don't get any sharp movement of the feet as it blends over 1/4 second from one animation to the other, because you know, we can get away with that fine when it's a fast animation, but when it's a slow animation, we're going to suddenly see if the transition is only 1/4 second, there's going to be a very quick movement of the feet as it transitions from idle into turn or from turn back into idle. So I'm just going to make that blend a little more gradual, like so. Okay, the next thing I want to do is I want to turn off, for testing purposes, our food source in the scene. Remember, that's our zombie cop dude here that has the food aggravator on it. So I'm going to turn off that object, because if we don't, we won't actually get to see the zombie turn on the spot until it gets all the way around here and after it's spent a few minutes feeding. So by disabling that food source, we know the zombie is going to go straight to its first waypoint, which is here. Okay, let's press play and see what happens. I think I'm going to move the animator window over here so we can see what's happening. Selecting the lower body layer, of course. Because remember, the lower body layer currently has a weight of 1, but this will be controlled by code in the end. Okay, we'll do that in a moment after we've added the upper body layer. I'm going to pause it now until she comes into the room. Okay, so here she comes. She's linked to a waypoint, and what we want to see is just, she's going to drop down into idle, and then she's going to do like a turn on the spot. Like, yeah, there you go. I like that. That's pretty cool. And back she goes. Okay, so I'm going to move the animator window over here. That's our lower body layer done. So our upper body layer is going to be quite simple. So let's add a new layer to our animator. Let's call this upper body. And I'm going to move this up so it's just beneath or above in the stack the lower body layer. And we are going to use a mask for this. Now you remember that originally we were going to use the lower body mask for our lower body layer, but we decided not to. But we do already have an upper body mask, and that's the one we're going to use for our upper body. So for now, just for testing purposes, I'm going to put the weight of this upper body layer all the way up to 1, so it's fully active, as if we've got lower body damage and upper body damage. And if I select the upper body mask, you can see that it only controls from the waist up. Okay, so the legs and the IK solvers on the feet are not being animated by this layer. So all I need to do now is I just need to find really just a single animation clip that I can put on this layer that's always going to be getting used. And you could create special turning motion fields and do a whole copy and paste of the locomotion framework that we did for the lower body layer. But I don't need to do that, because if I find the animation I want to use, I think it's this one here. See this damage upper left? There you go. It just has sort of an arm hanging down limp and another arm here that's kind of up at an awkward angle. I'm not quite sure, looking at that, whether that would be the left shoulder damaged or the right shoulder damaged, but it doesn't really matter. I've got left and right versions of it. And when the player has upper body damage, his upper torso is just going to look like this. It's going to hang in an awkward way. So I'm going to drag over damage upper right. I should just check that is a looping animation, isn't it? Yes, it is. And then when we press play now, this is already going to be active because I set the layer weight to 1. And let's see now what our new idle looks like with the lower body layer animating the legs and the upper body layer animating the upper half of the torso. Yeah, so you can see it looks kind of like he's sustained some arm damage. Now, of course, guys, you have access to all the animations that you want, so there's no reason to stay to just my animations, because I've really limited myself quite greatly here to just animations that I can get hold of for free and that I can distribute to you. So there you can see that's what a zombie is going to look like if it's got lower body damage and upper body damage, but not enough lower body damage to make it a crawl. And of course, if I choose the upper body layer just a second and I move the weight of that down to 1, we're going to see him now in a normal walking. So he's got no lower body damage now, but he still has, or she still has, the upper body damage, like so. So that's pretty cool. So what's it going to look like when it goes to the patrol state? Yeah, you can see there's a normal patrol state on the base layer, but her upper half looks really weird because she's been damaged. And just to remind you, if I move the animation window over here, and I put the lower body weight up again, you can see that's going to turn her into a limp on the lower body. So it looks pretty cool, doesn't it? Okay, that's good stuff. So that's all that's involved in getting our upper and lower body layers set up. So all we need to do now is just add some code to our zombie state machine that's going to make sure that these layers have their weight set to 1 or back down to 0 at the appropriate times. So let's do that now. Okay then, so I'm going to select Zombie Jill in the hierarchy, select her AI entity game object, and in our inspector I'm going to double click on the AI zombie state machine script to open it in MonoDevelop. And the first thing I'm going to need to do is add 2 new variables of type int to our AI zombie state machine that we can use to cache the integer index of the layers that we're going to need to talk to at runtime, and that is of course our lower body layer and our upper body layer, called lower body and upper body respectively. So I'm going to scroll down to where the AI zombie state machine class definition begins. I think I'm going to put these variables under the block that I called hashes, although technically it's not a hash. It is all to do with talking to the animator, so I'm going to put them here. So I'm going to create a private int, and I'm going to call the first one upper body layer, and by default I'm just going to set this to -1, because what we're going to need to do is use some functions of the animator in the start function to query the index of these layers. So I'll call the second one lower body layer, set that to -1 as well, and then I'm going to scroll down to the start function, and just underneath where we call the base class version of the function, I'm going to say lower body layer equals animator dot get layer index, and this function just takes a string, which of course is the name of the layer. So for this one it's just lower body with a capital L and a capital B, like so. And then of course we're going to do the same for the upper body layer as well. So get layer index upper body. Oops, have to put a space in between there. This string of course has to mirror exactly the name that we've assigned it in the animator, even with any spaces and capitalization. So what I should probably do, just to be safe, is I should just say if animator doesn't equal null, like so. Just so we don't try and fetch properties from the animator if for whatever reason we haven't got one. But of course that should never be the case. And I'll put a comment in there saying cache layer indices. So now we have these layer indices, we can use them to alter the layer weights in our update animator damage function. Now remember, our update animator damage function is the function that is called whenever our zombie takes some damage and we need to reconfigure the animator's parameters, and in this case layer weights, to reflect visually the new state of our zombie. And of course at the moment all it does is it just sets the is crawling boolean to true or false, and it also sends in what the lower body damage and the upper body damage currently is, which remember are these parameters here, because we saw earlier on in the lesson that these are used in some transitions on the cinematic layer. But all we have to do in our code now is we just need to check the lower body damage, and if it's larger than the limp threshold but smaller than the crawl threshold, then we need to turn this weight up to 1. Actually I should probably put IK pass as well on the lower body layer. But in the case where we've either got no damage or if we're crawling, then we wish to turn this back down to 0 again. It's very important if we're crawling we set these back down to 0, because we want to use all of this crawling logic that's set up on the base layer, and if the lower body or the upper body layers are set with a weight of 1, that's going to override anything that's happening on the base layer, and we're going to lose all of our crawling animations and logic. Okay, so what I'll do for now actually is I'll set both of these layer weights down to 1 now for the upper body and lower body layer, and then I'm going to go back to our update animator damage function, and in the if animator doesn't equal null block, the first thing I'm going to do is check that we have a valid lower body index layer. Okay, so we're just making sure that it isn't still -1, and assuming it's not -1, then we have got a valid indice for the lower body layer. Then what we're going to do is we're going to use the animator's set layer weight function, and we're telling it that the layer that we wish to set the weight of is our lower body layer. And then what we do here is this conditional that says if the lower body damage is larger than the limp threshold and it's lower than the crawl threshold, in other words if we're not crawling, then we're going to set the layer weight to 1 Otherwise, in all other situations, we're going to set it to 0. And now we're going to do something a little bit similar for the upper body layer processing. So we'll say if upper body layer doesn't equal -1, that means you've got a valid upper body layer index. Then we do a similar thing. We use the animator set layer weight function again, this time passing in the index of the upper body layer, and this time we're saying if the upper body damage is larger than the upper body threshold, which remember is another property of our AI zombie state machine. Here it is here. Upper body threshold, which is currently set to 29. So in other words, when the upper body damage gets to 30 or above, then the upper body layer is going to kick in and we're going to start to see some damage to the upper body. But also, again, being careful to check that the lower body damage threshold is under the crawl threshold, because remember, we do not want to activate any of these layers if we're crawling. We want the base layer to kick in. So if we do have upper body that is greater than the upper body threshold and we are not crawling, then we're going to set the layer weight of the upper body layer to 1. Otherwise, we're going to set it to 0. And I'm going to save that off. Just check I haven't got any errors. And what we should see now, just for testing purposes, I'm going to set the weights of the upper body and the lower body layers up to 1. And then assuming that our zombie hasn't got any initial upper or lower body damage, we should see those weights immediately be set back down to 0 when we press play. But let me just check I haven't given us any damage to begin with. So I have. You can see I've given us lower body damage to begin with. So if I press play now, and I will move the animator window over here so I can see the weights of those layers, we should see these grey bars drop down to 0. There you go. And you can see, look, the weights have been set down to 0. But if I stop that and then select Jill in the hierarchy, just for testing purposes, and I will put her upper body damage up to, let's say, 60. Okay, then what we should see when I run this now is the lower body layer should have its weight all the way back down to 0, but the upper body weight should stay up at 1. So we should see a full grey bar stay there. Yeah, there you go. Or a blue bar, actually, when we've got it selected. So you can see the upper body is correctly activated, but because we haven't got any lower body damage, it's down at 0. So that's pretty much all we need to do now to activate lower body and upper body damage visually in our game. So what we need to do now, just to test all this stuff, is I'm going to select my FPS controller rig, and I'm going to open up the character manager. And remember, the character manager is the script where at the moment we're kind of faking the gun that we've got. And that's in our do damage function. And whenever the mouse button is pressed, you'll remember that this function casts a ray through the crosshair in the center of the screen, and we get the zombie that we've intersected, if we've intersected a zombie in our crosshair, and then we call that zombie state machine's take damage function, and we pass in the characteristics out of the weapon. So just to make things easy to see, remember the second parameter is the force that this weapon applies to the zombie, not the damage. So at the moment we're applying a force of 5 in the direction at which our ray is cast. In other words, the direction at which our bullet hits the zombie. I'm going to put this down to 1. Okay, so we're going to not be applying any blast damage to the zombie. So you can think of this as being how a pistol or a sniper rifle might handle. And what I'm going to do is I'm just going to give it a damage of, let's say, 50 points. So if I shoot it in the upper body, it should have an upper body damage of 50, and we should see it after it's kind of recoiled back. We should see it come at us again with the upper body with that limp arm. And if I shoot it in the legs, it will fall over, because our zombies always fall over when we shoot them in the legs. But when it climbs back up again from the ragdoll and starts coming towards us, it should start limping towards us. So that's the plan anyway. So I'm going to go back to the editor, check I haven't got any errors. I'm going to maximize the game window on play here. I'm going to turn my flashlight on. And oops, my zombies already started off with upper body damage, which I don't want. So let me turn the upper body damage down. Press play again. Sorry about that, false start there. So let's wait until the zombie turns round. Then I'm going to shoot it in the chest to begin with. And you can see, look, now it's coming at me damaged. I'm going to shoot it in the legs. And now when it gets up, what it should have is a limp. Yeah, you can see it's using our limpy turn. I'm And I think if I shoot it in the legs again, that'll take it to 100% damage, and it should start crawling after us at that point. So there you go, but it can't actually get anywhere because I've actually damaged its legs so much that, because I've given it 100% damage in the legs now, which means it can't even crawl forward. It can just move its arms. And if I shoot it in the upper body again, I don't think it can even, at this point, I don't think it can even move now. But it's still alive. There you go. It's lost any means of propulsion. But in a real game scenario, what we would probably do is any ranged weapons like pistols or rifles, we would probably give them a damage of 100. So they do 100% damage. Now remember, if we do 100% damage to the upper body, not really a big deal. It's not going to kill the zombie. It's just going to apply upper body damage. It's going to bring up that damage layer. But it does mean that if we give it 100% damage, then any headshots will kill the zombie outright, which is often what we want. But in the case of shooting in the legs, well, a lot of the time, if you're shooting it in the legs with a rifle and you're doing a lot of damage, then it's not even going to be able to crawl because it's going to go straight to 100% damage on the legs, and you'll get a situation like what we just saw, where the arms are still waving around trying to get to you, but the legs have lost any means of performing any sort of locomotion for the zombie. So you might be thinking, well, in that case, that means that crawling is never going to get used at all, right? If we set all of our weapons to have 100% damage, but that's not necessarily the case. Firstly, remember, we may choose to configure some of our zombies at startup so that they are crawling zombies, but also remember that although we're talking about using this take damage function at the moment in the terms of a pistol or a rifle, remember this is also going to be used for melee weapons as well, and it's quite possible that a melee weapon might just have a damage of say 30, so you might have to whack the zombie in the head 3 times with a crowbar or a wrench to actually kill it. And of course, if we're attacking a zombie in the body or in the legs with such a weapon, then we're just causing sort of smaller increments of damage to the various parts of the body, and that's when we're going to see the full gamut of animations that are available. So that's this lesson complete. Like I said, my system is pretty basic just because I've only used one upper body animation and one lower body animation. But of course, the framework has been put in place by me for you to be able to develop this how you like. In other words, what you could say is once the upper body damage goes past the upper body damage threshold, you have various stages of damage, so multiple motion fields on each layer so you can see it. But just to demonstrate it, I've just used one state of damage on those layers. You also have the ability, if you want, to manifest left and right body damage more realistically, but you will need to add a few more tags and change a little bit of processing in the take damage function just to identify which side of the body has been hit and pass that data into the animator so that you can trigger either the left limb or the right limb, etc. But I'm going to leave that as an exercise for you, because if you've got to this point in the training, that really shouldn't be a problem for you. And if it is a problem for you, well then that's a problem for me too, because it means you might not have understood everything I've said up till now, but hopefully that's not the case. So thanks for lending me your ears, guys. Next time I think what we'll do is we'll have a nice light little lesson where we'll talk about adding sound emission to our character, so that when we're walking we can creep up on zombies without them hearing us, but when we run at a zombie we're going to create a larger sound footprint, and it will kind of have an effect like we're almost shining a torch on a zombie. So if we're trying to sneak past zombies, we want to walk past them, but if we try and run past them, we're going to make more noise, and a group of zombies might hear us and start to investigate where that sound came from. In other words, start to seek around to your position. And I think I might also talk about, and perhaps even show, how we could also use that system to simulate almost a kind of a smell system, so that when you get more damaged, you essentially make zombies be able to smell you. Now, we could add an entire sensory system for the zombies, but what I'm going to do is discuss how we can piggyback off of the sound system that our zombies have to essentially give the appearance that they have a smell system. And that's simply by saying that as we get more damaged, we also emit a louder sound footprint. So even if we're perfectly still, if we're covered in blood and we're quite close to a zombie, it's going to be like we're making a sound to that zombie. But of course, from the player's perspective, they won't hear the sound, because the sound really is just a collider that's intersecting the zombie sensor trigger. But what the player will see is they will just suddenly see that when they've got more damage and there's there's more blood on the screen, that as they start walking past zombies, the zombies stop what they're doing and they start seeking around almost like they're smelling them. Okay, so that's what we'll do in the next lesson. I think probably after that we've got one more lesson, and that's going to finish up phase 1 of this training series, where we're going to move away from AI and move into the second phase, where we're going to be talking about interactive environments.